Yo, what's up? Welcome back. Today we're working on my Git GUI, kind of. We're a couple steps down the rabbit hole, but we're kind of working on this Git GUI. And one of the things that our Git GUI does is he shows, like, when you click on a commit, it shows the commit message, but it also shows the diff associated with it, right? Obviously, like, that's like the one thing that you would want to do. And part of what we've done here to do this is we've like implemented a version of the Myers diff algorithm. You might ask, why would you do that yourself? There's reasons, you have like more control, you build better intuition about what it's doing. It lets you kind of like tack on extra stuff. Like, for example, we have move tracking in here. So if I bump the memory here, we can see like there's like highlights of like, oh, this stuff was moved from this other part in the file. So there's like reasons why it's like beneficial. But probably not worth the effort. But one of the problems that we're hitting right now is there's a version of the algorithm that's like provided in this like paper from this guy in the 70s. And he says like, hey, we're basically going to do this like tree walk. Like, well, we'll get into the details in a bit, but essentially there's like a breadth first search that you can do to build this diff. And as you're doing your breadth first search, you have to remember every single pathway that you're taking. Because once you get to the end, you have to go like, oh, that was the right path. So how did we get here? And now we can build our diff. And that's like an n squared memory usage. And so what happens by lines, like by like items that you're comparing. And in our case, we're comparing line by line. So what happens is if we have like a not that large file, you can end up with like 300 gigs or like a terabyte of memory attempted to be allocated. Problem. So we started working on this like linear version of the algorithm. This is like the visualization of it. So you have like this the x-axis here is the source string, and the y-axis is the destination string. So you can imagine that if you wanted to go like, from like 1, 2, 3, 4 to 1, 2, 4, 3, the x-axis would be 1, 2, 3, 4, and it would look something like, actually, we can probably draw this. Let's see, it's dash a 1, 2, 3, 4. Certainly we've done this, yeah. So this is a representation of that 1, 2, 3, 4 to 1, 4, 2, 4, 3. And the idea is that diagonals mean that like the source and destination are the same. X-axis means that you're moving along the source string, and y-axis you're moving along the destination. So if you were to like do this by hand, you would say, okay, well, 1, 2, 3, 4, 3 has a 1 and a 2. This 3 is not in the right position, so I'll delete it. And then we have a 4, that's there. We have the 3. So in this case, we're saying like 1, 2, those are there, so we go diagonally. Then here we say, oh, well, the 3 and the 4 don't match up. So what this version of the guy decides to do is he looks at like both options, and he gets to the end, he says, okay, I'll delete the 3, and then I'll use the 4, and then we're there. And then I'll add the 3 back. And so here is like a more complex version of that visualization. And what happens is as it's the memory usage starts going up, we can implement this like version of the algorithm that essentially walks forwards and backwards at the same time, remembering nothing, right? So we don't know how we got there. But when they collide, he can say, oh, we can split this into 2 subproblems. And we can kind of like keep doing that until we break it into small enough problems that we're not using enough memory. And then we can run like the expensive backtracking version of the algorithm on these subsections. Great. Implemented that, and we started seeing these cases where we're still seeing like pretty high memory usage in some cases. And so we want to know why. These cases are now, instead of like, this is like a what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 by, I don't know, 13 or something grid. This is like, we can visualize this and like build intuition off it. But in the cases that we're seeing like problems, we're at like 4,000 by 4,000 lines or 5,000 by 5,000. And so what we're hitting is the actual rendering process that we're doing here to visualize is too expensive. We're using this library eGUI to render our stuff. It's great. But what it does when you're saying like draw a circle, draw a line, is it pushes like this like shape structure to some list of things to be drawn. And at the end of the frame, it will go, oh, okay, I've got all this stuff to draw. Let's draw it now. And we were seeing that like the scaling of that was not good enough for us. So like it was storing too much, and so the memory usage of just trying to render the graph was too high. And so that's what brings us to today. We're working on like replacing our eGUI style visualization with a OpenGL one. So where we got to yesterday was we got to the point where we're like feeding in data. We have like our graph being drawn here, but it's like kind of ugly, and we have no way to like step the algorithm yet. But the thought is that once we get this into a working state, we should be able to do something like add the ability to pan and zoom and do whatever we want to do. So yeah, that's what we're working on. So I think the steps are, we probably want to draw like algorithm progress like we were in the previous version. We want to like adjust this so that it's like taking up the full screen, because we kind of like copy pasted this example from eGUI on how to like integrate OpenGL stuff, and so it's kind of like fixed to whatever size that example used. We need to implement like pan and zoom, because when we get into this like 4,000 by 4,000 case, there's going to be too much information on the screen, so we have to like find a way to like narrow in. And I also forgot that we want to add in the box rendering, or like sub problem rendering, I guess we'll call it. So like when we run it forwards and backwards and they collide, we need to show where those sub problems are being, like where the sub problems are. And yeah, I think that's all we have to do for intro. So let's kind of like jump in. Okay. So let's look at drawing algorithm progress. So what does that entail? What are we doing right now? Right now, we have a bunch of code that isn't actually being used. And we're doing this like custom painting thing. I have to refresh my memory from yesterday. Right, and so he calls this like rotating triangle thing. It's called rotating triangle because we're starting from an example of a rotating triangle. And it looks like this guy's in charge of doing all of the actual work. Right. So what we did was we passed in our like source and destination strings. He converted those into like OpenGL buffers, and constructed a program, like an OpenGL shader program, to draw both the points on the grid as well as the lines. And so now I guess what we want to do is we want to say, okay, so those were like the static grid, and we can construct that at the beginning. But then we have like all this like other stuff that we want to draw on top, which I guess means that we're probably going to reuse the same like shader programs that we were using before, right? We have like a program that we call to say, hey, draw circles at these points as well as draw lines at these points. And I guess we're just going to want to draw different lines. So probably we're going to add some sort of function here to be like set algo progress. Yep. And he's probably, what I think that I'm going to do here is we're going to generate some buffers of like where the algorithm that represent like the lines of where the algorithm is walked, I guess, as well as the points where the algorithm is walked. So it'd be nice. I would like to have like the original version as like a reference point. So maybe what we can do is we can build the old version. So I'll check out this cargo build. I guess diff viz. I only care about the visualization stuff. I guess I have to build everything. Fine, I'll build everything. Yeah, so we're gonna need buffers for. Sorry, my brain's melting. So I wanted to back this up. So I wanted to say copy diff viz to like diff viz backup. And then I should be able to go back here and say cargo run. Target debug diff viz backup. And there we go. Okay, so now we have like a reference. And so we're going to have storage for these lines of like algorithm progress, as well as like different colorings, as well as a circle rendered for like where in the algorithm we are right now. Sounds reasonable. Sounds reasonable. Okay. So git checkout viz. And we can keep moving. Okay. So what were we doing? We were in the rotating triangle thing, which is a bad name, which we'll fix later, but we'll deal with that in the future. And I guess let's add like a buffer for algo progress lines, I guess, as well as a current node or highlighted nodes. I guess these will have to be uploaded into some buffer, so storing them as a glow buffer makes sense, like an OpenGL buffer, I guess, makes sense. And so then whenever we say we want to update algo progress, we're going to use our OpenGL context as well as the debug info. Which I don't remember the type of. We're going to have to use this to like update those buffers. Okay, so he's going to be annoyed somewhere that those buffers don't exist, so algo progress lines are going to be create buffer, and this is going to be, what would we call it? Algo progress lines and highlighted nodes, I think is what we called them. Nice. Nice. Okay, let's figure out where this, like, what the types of this debug info is. Okay, so we use it here where we say debug info comes from the debug info. And I guess technically there are like two states for this, but we're going to focus on this one for now. Linear algo debug info. Who's got sub infos of, okay, got it. Okay. Sorry, I've just got thinking of like how to articulate this. So I think what I'm going to want to take in here, I think that maybe let's just say that we'll take in some nodes to highlight. Yeah, that seems reasonable. So this is going to be a vec of points in what we were calling grid space, right? So like the top left node would be 0, 0, the bottom right would, the next one over would be 1, 0, etc. And then the lines will also be in grid space. And I guess these will be like pairs of positions, which isn't great. Maybe this should be like a proper struct of some form, but fuck it, you know? No, I'm gonna, we'll make a struct. Fine. So this is going to have, like, start is going to be a point, and end is going to be a point. And I guess then we should have a struct point. Fine. We'll fucking do it. Which means that these guys will take in, nodes will be a vector of points. And lines will be a vector of line. Fine. Okay, so what's he going to do? He's going to update the buffer data with this stuff. Sure. So I think there's like buffer sub data U8 slice. Nice, that looks promising. And he takes in target, offset, and source data. So the target, I think, is glow array buffer, I think, if I remember correctly. Let's look at the... fuck, my indexer is broken from that. Buffer sub data U8 says target offset source data. So I guess maybe target is the buffer. Oh, I see. So this is if the buffer is bound. This is probably the one I want to use. I want to say, hey, here is the. I have a buffer sitting around. Could you please update it? That's probably the one I want. So named buffer data U8 slice. And so here I pass in self line buffer. Okay. Yep. And then the data, I need some data. Right now we have like a vector of lines. We're going to have to like convert that in some way. And what else does he have? Usage. What is usage? Do I have a Firefox one open? Looks like no. So GL named buffer data. GL named buffer data substitutes the buffer. Oh, but maybe I do want GL buffer sub data. GL named buffer sub data. That's what I'm looking for. Named buffer sub. Maybe we don't have the ability to named buffer sub in this like OpenGL bindings. So I guess we'll do it this way. And target is supposed to be, array buffer. Offset specifies the offset into the buffer's object data store will replace it with begin. So the beginning specifies the size that will be replaced and specifies a pointer to the new data. Okay. Yep. So I already forgot. Offset is going to be 0. This is glow array buffer. And then we need to like take this vector of lines and turn it into something that we can feed into OpenGL. And I wonder... No, we shouldn't. We could technically rely on the data layout of these structs. We could say, like, repr packed. And if we do that, we actually end up with, like, the correct storage, I think, where we would get... This would show up looking like x1, y1, x2, y2, like the beginning and end. That's how this would end up in storage, but I don't think that we need to bother with that. Instead, we will just allocate a new buffer. Fuck it. So we can say, like, we want to look at our lines, and we want to maybe... Ooh, we can get crazy here. We can get crazy. So if you do lines into iter, like this in Rust, and then we say, we're going to map these lines from, like, L into L start X, L start Y, L end X, L end Y. And I think this is flat map, yeah. And then we collect this into a vector. So we'll say let line points is a vector of I64. I think this will actually... This might compile down to, like, a no-op. It might. Because I know that Rust does this shit where you, if you, like, create a vector, turn it into an iterator, and then do some operations on it and collect it back, it is actually smart enough to reuse the same allocation. So, like, this actually might... I'm pretty sure this doesn't result in any allocations, and it might be smart enough to notice that this is the same fucking data layout, and it might just do nothing, which would be very fucking cool. I don't know if it'll do that, but it could. That's like an optimization that it could make if it wanted to. Okay, so now we need to, like, do this, like, bullshit where the, like, OpenGL API, it is expecting these line points as a bunch of I64s. Kind of. We, like, we can tell it that they're I64s, but the, like, API to, like, upload data to the GPU does expect U8 slice, which means that we have to, like, just do some unsafe casting, which is super cool, super cool. Which I think we have an example of here. So we do something like line points U8 is we take the line points as a pointer, and then these are I64. I guess we want these as I32s. So now it definitely won't do that optimization where it does a no op, but it might. It will still probably reuse the same allocation. And I guess we should like assert. Fuck it. The code like this like I64 to I32 cast is kind of stupid. Like there's a chance that this will not work correctly, but I don't know if I want to deal with it. So we'll just say I don't like it, and then we'll deal with it later. Okay. So this needs to be unsafe, of course. Of course. Okay. And so now, theoretically, we have a way to like update our lines, and then we need to paint those lines as well. So we're using our line program. We've specified our like uniform, so like data that we need to feed the program so that it knows how to like do the conversions between grid space and like screen space. Then we like bind this buffer of our like line buffer and say draw those. But I think that we should be able to just bind a different buffer and then draw again. So here we should be able to say, hey, could you please bind the algo progress lines buffer. So that's here. And we also have to keep track of how many elements there are in here. So we don't actually know. So num algo progress lines. And surely there are like there's stuff in here that should be split out. But we are not worrying about code quality yet. We're going to come back for it later. Although sometimes I say that and then I get bit because it turns out that the reason that you improve your code quality is that you make less mistakes, and I make mistakes and then get mad. But you can't fucking stop me. So here we need to bind the buffer before we substitute the data. So this is the algo progress lines. Then we bind nothing. Say, hey, we're fucking done. Don't somebody else who's gonna come in and do stuff, don't fuck with me, please. Don't break my shit. Okay. So far, so good. And then we need to store the number of lines. So here we would say num algo progress lines. Num algo progress lines is going to be line points len over 2. I think. How many lines there are? Here we said num just like we just wrote them down, but I think that's wrong. I suspect that here we were supposed to divide by 2 as well. We'll see though. Right, because there's 2 points per line is kind of what I'm thinking here. Oh, no. This is the number of vertices, not the number of lines. Okay, yeah. It is the line points len over 2. No, over 2. Over, because there's one. I actually don't know. We'll just have to look up the fucking docs here. So when we draw arrays, what is the fucking last count? Specifies the number of indices to be rendered. Where index refers to collection of elements, I think. So I think it should be divided by 2, but we can test this pretty easily. For now, I'm not going to, but we could. So I'm just gonna put a little fix me on here. Wait, did I not store the thing? I thought I did. Self.num algo progress lines equal to line points.len, and we'll say fix me maybe divide by 2. And we'll put that fix me here as well. Okay. Is there anybody else who's complaining here? Num algo progress lines should be 0 up front because we haven't actually added anything. And here, this guy needs to be mutable. Okay. And so now what we should see is this should still be how he was. Great, everybody's happy. And I guess also the algo progress line should be a different color. So probably what makes sense is in the fragment shader here, we should have some sort of like uniform vec4, which is going to be desired color. And we are just going to unconditionally render with that color. And I think you can set a default value here. I think. Not really sure. We'll see. Okay. And so let's start by just saying, what if we made this like green? Everything should render green. Okay, that's good. The lines are now rendering green, like we expected. And then let's do something like before we render the grid part, we will set the uniform desired color. And I think it's like uniform 4 F32 because it's a vec4. And so he has a location and then X, Y, Z, W. So here we set like 1.0, 1.0, 1.0, 1.0. And then before we draw our like extra lines, we change the color to green or something. Do you know any other fancy languages besides Rust? I don't know what fancy languages means, but I do know other languages. Depends on what you're asking there. Okay. So everything's green, which seems like a problem. I expected these things to be white. So here it's white. Here we draw some stuff after setting it to white. Then we set it to green. And we should... oh, this guy should be... self dot num algo progress lines. This should be a I32, I guess, which means that whoever assigned to him should be as I32. Any other languages you enjoy working with? I mean, Rust is my favorite, but I mean, C is cool. C++ is okay. You know, I've done some Python here and there. I don't really like JavaScript, but it's like a necessary evil. Yeah, I mean, I don't know. I would like to give Zig a shot and Go a shot at some point. I just haven't got around to it. But yeah, I don't know. I find that like in reality, I don't think that programming language matters that much, right? Like it's one of those things where it's like you have preferences and some languages align with your preferences better, but like really it shouldn't be a big deal is kind of the way I think about it. Like you should be able to get anything. You should be able to be productive in any language. But I do heavily prefer static typing, and Rust is like, it takes the static typing neuroticism to like the next level, which I like. Okay, so let's try feeding in some lines to draw here. So let's say that we want to draw some lines. Let's see, how do we want to do this? Maybe before we do custom painting here, we'll just say update algo process. Update algo progress. Okay. I guess here. And the nodes will be an empty vector for now. But let's add some lines to draw, just for testing. These also needs the glow context, so I don't know where that comes from. I guess we have to do it in here. So here we'll say let rotating triangle is equal to self rotating triangle lock unwrap. And then we can not lock it twice here. Okay. And in this vector, what is it complaining about here? It needs, all right, painter GL. Then, is it still complaining? Cargo check. Method not found. Oh, because this is like this now. Right. Okay. Okay. Solid. Ooh, now it's mad about something else. Requires that something is static. What is it complaining about? Self escapes the method body? How has anything changed here? What the fuck? Oh, oops, I'm supposed to use this. There we go. Yeah, I'm supposed to use the shared reference. Got it. Okay, so now let's feed some lines in here. So this is gonna have like a line, which is a start, comes from point. Let's just give it like x0, y0 for now. And give it an end of x2, y1 or something. The reason I want to do it this way is this line will not line up with anything else on the grid. So it means that if we see that line, then we're like, we've fucking done a good job. And so let's try running that and see if we see it. I imagine we won't. Surely we fucked up. Okay. So that's kind of interesting. We are seeing some line here, but it's just not what I expect. It's drawing the first two lines from the original data, it looks like. I'm pretty sure. So it's almost like we have to tell the vertex array object probably that we've updated the data or something. If I remember correctly, I think we read yesterday that rebinding the buffer does not necessarily change this. So maybe we have to call this again. Let's just double check. So yeah, we set the buffer data, we bind the vertex array. Uh-oh, so maybe we do it down here actually. When we render, we switch the buffer and we say, hey, could you please draw this one now, please? Yeah, that sounds right. Let's see if that does it. Still nothing. Still nothing. Okay, let's just double check. So here we bind the algo progress lines, which is what we updated here. And he's clearly not drawing it. So let's think about this a little bit. Let's maybe log. Well, before we log, I'm just going to I'm going to swing randomly. Just to see. I suspect that this is also related, but we'll find out. Okay, so that's a good sign. Something happened. We are now no longer seeing the grid of lines. So we did something there that is helpful and relevant. But not helpful and relevant enough. May not be a related question, but what do you think about the Go language? It seems nice from the the little bit that I've looked at. Seems like simple, and simple is good. Right? Like one of the problems that you'll hit with Rust is like there's a lot. It's just a lot. And there's a lot of ways to get confused and a lot of ways to mess up. Go is just like the language looks like it provides very little. But again, I haven't written anything in it, so it's hard to know. The only way I know Go is I looked at learn X in Y and clicked on Go here and skimmed it. You know, so it's like all I've done is like read this, but it seems like decent. I don't know. I don't think it matters. Someday we'll find out. Someday we'll find out. So why is this not doing what I want? GL getter might be helpful for debugging, but I don't know. I think that the Rust API is supposed to like check some of this stuff for me. So I'm not really I'm not worried that I'm doing something like invalid as much as I'm just doing something wrong, if that makes sense. Like I don't know if like there'll be errors that come out from this problem. Let's just look up the binding vertex array object, or updating data in vertex array object. How should I update a vertex array object when I update a vertex buffer object it uses? That's exactly what I'm asking. You don't have to worry about that because VBOs never expose the underlying server memory to you. Blah, blah, blah. Vertex attribute pointers will be relative to the beginning of the object bound to GL array buffer at the time you set them. Okay. So even if you reallocate the buffer, blah, 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 your vertex attribute pointers are not going to be invalidated. Great. So that's kind of saying that when I substitute the buffer data, I have to re-update. I have to like reset the array object as well, which is what I did here, I thought. This is getting unruly, hard to manage. I guess maybe what makes sense here is we will also have algo progress array. And that feels a little better. That feels a little better. So here we can say algo progress array is going to be GL create vertex array. And then when we update this guy, we have to bind him, GL bind vertex array. And that's sum of self dot algo progress array. Then we set the attribute data. So we say, hey, I would like to enable this thing and give you some points. GL bind array. We'll unbind the vertex array here. And then down here, we can delete these enables, blah, blah, blah. And before we draw the second set, we say GL bind vertex array sum self algo progress array. Okay. Maybe. Not 100% on that, but let's see what we see. So no green lines at all anymore, which is interesting. Let's see. Print line. What do we expect to see here? Self, num, algo, progress lines. I'd like to see if we're trying to render anything. We are trying to render 4 lines, which is probably wrong. We're probably supposed to be trying to render 2 vertices or something. Let's look at when we generate the other vertex array. We create a vertex array, we create a buffer, we bind the buffer, we cast it to the thing, set the data in it, bind the vertex array, set the data, blah, blah, blah. Okay. So looks similar to what we were doing here. We bind the vertex array. I guess we bound the buffer first here. Not that it should matter. So here we bound the buffer. We set the data. Let's maybe try buffer data U8 slice instead of this like sub data slice thing, just in case. This is the same. This is the same. Then we update the number of points. Unbind the arrays. Okay. Then when we draw, we... Oh, here we bound the buffer. We probably don't need to do that, but worth comparing. Worth comparing. Oh, here we go. That looks right. So here we have that one green line that we just added at the top left, but everything else white lines, and they're also there. So we're kind of chilling there. And then I would also like to double check this like algo progress lines thing. So I think that he should be over 2. I think. Yeah, okay. Chillin'. So surely we are struggling with things being like the level of abstraction being a little bit wrong. It would be nice if maybe this like buffer management stuff was like abstracted in some way. So I think probably it is time to split out some sort of like buffer data thing. I don't know how I want to call this. Maybe we'll call it like grid vertices, we'll call it maybe. And he's going to have the array object, which tracks like the layout of the data, the buffer, which tracks like the data itself, as well as how many elements are in it. Okay. And so maybe we will find a way to construct this guy. So what is he going to be? I guess he's going to take in probably just a list of points. Because like a line is 2 points, or yeah, a line is 2 points, a triangle is 3 points, a point is 1 point, and it's like none of that really matters with like the management of the data. Like it's all kind of like the same from his perspective. So he's got a vector of points, and he's going to return a grid vertices. And so he's kind of just going to do, he's going to like basically call this function. Close. So he's also going to need to take in an OpenGL context. And he's probably also going to need to like convert these points into like a flat array, I32 2D points to VBO, VBA. So this guy is taking in like what? Just a bunch of I32s, yeah. So he's going to say let points I32 vec is going to be points into iter map x, or p, I guess, into px, py. Sure. I don't know. And this is going to be buffer array, and then he's going to return this like grid vertices array buffer, and then num vertices is going to be let num vertices is equal to points dot len. There we go. Yep. There we go. Okay. Sure. He doesn't like this for some reason. I don't really know why. Let's just try some stuff. There we go. That's working better. And this is also as I32. Okay. And then fix me as casts are sketch as fuck. Okay. And I guess we should probably also impl drop for grid. I think we can't impl drop because he needs to use the OpenGL context drop. Fuck it. We'll just like let all memory stay there forever and never deal with it. That is how we're going to manage for now. So let's start by replacing the circle stuff with circle data is circle vertices is going to be grid vertices. Okay. And so we're going to delete all of this stuff. And then when we construct this guy, we're going to say, let circle vertices is equal to grid vertices new using the OpenGL context and the list of vertices. And then down here, we can just say, here are circle vertices. Yep. And he doesn't like the arguments here because these are supposed to be a vector of points. This should be a point xy. Yeah, that looks right. Point is not an iterative trait, so here we like map each of these to a point xy. This should be a vector of points. I think the points are I64s for some fucking reason, even though there's no real reason for them to be. Okay, and then when we render these guys, maybe we call self circle vertices bind. Or maybe we just bind the vertex array of self circle vertices dot array. Sure. And then we say self circle vertices num vertices. Okay, and then I think that all of that kind of works out. I think. Not really sure, but we'll find out. Looks good. So all of the circles are still being drawn. So looks like the abstraction is fine. Okay. I guess technically we don't need to store the buffer because the buffer is like the data pointed by the buffer, like what we read earlier was that the buffer data is attached to the array object. But then like if you delete the buffer data, the vertex array object will like hold a reference to it forever until you reset it. So maybe we don't need to deal with that, but it's fine for now. It's fine for now. Okay, so now we're going to do the same thing with line. So we're going to call this like, maybe we'll call it like static lines. Is also going to be a grid vertices. Okay. And so this is going to be line vertices are going to be a vector of points. I don't like the like I32, I64 bullshit that's going on here, so I'm just going to change these to I32s now. Which means these guys have to be I32s here. Okay. Now all of these guys are going to have to return points, I guess. So this is going to be a point of 0, x, 0, y, and a point of x is this, y is y, something like that. Yep. X, y, 0, point x, y is whatever the fuck this is. Okay. We're getting close, we're getting close. This guy has to be a point. This has to be x is like as I32, as I32. Gross, 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 gross. There's a lot of problems here, but we're gonna just kind of fly by them because I don't want to deal with it. This is point.y as usize, point dot, Jesus. I don't think that this is how I wanted to manage this. Okay, so we want to create a points down here. Yeah. And this is y is I32. Here it is. Here it is. Surely that's it. There we go. Okay. So now we have like our vector of points, and we construct our let line static lines is equal to our grid points, grid vertices new, using OpenGL and passing in the line vertices. Okay. Holy. Okay. And then down here, when we draw them, we have to bind the static lines array and render static lines num vertices. Okay, holy. So hopefully we still see like a reasonable grid here. Yep, solid. And now we just have to do that same transformation on when we update algo progress. So line points, we're going to make a vector of points, which is this, and it's just going to be L start and L end. Yep. Holy. And then here, instead of doing all this stuff manually, we'll just create, we'll just reset the line points in this guy. So grid vertices, we're going to maybe give them like an update function. Is this just for a diff algorithm visualizer? Yeah. Yeah, it is. We're down the rabbit hole a little bit. So I did find that the existing visualization was like extremely helpful. Like every time I make visualizations, I immediately see payoff. In this case, I think that we might be trending too far down the line of we're doing a lot. But this is also good practice, so it's not the end of the world. Not the end of the world. The hole is deep. Yeah, I guess because not only are we like deep down the hole, like in rendering this diff visualizer, we're only rendering this diff visualizer because we were using too much memory when we rendered our diffs for our Git GUI. So, is this even worth watching? I have no informative education. I mean, you get to pick if this is worth watching to you. I don't know why any of you are here, right? I don't know, I watch like some of this content, and I don't know why, like, what everybody gets from it is different, right? So if you're like, I'm not learning anything, and so I don't want to be here, like, I'm not forcing you, right? But, I don't know. It's like, it's up to you, right? So I'm having fun, and so I'm streaming it, and I'm writing some code. Just for shits and giggles, this is awesome. Yeah, I mean, like, sure, whatever floats your boat. But I'm just trying to say to the one guy asking, should I be watching this? Like, I don't know. It's up to you. I was struggling the other day with, like, the concept of, like, it's just so stupid. It's so stupid. But, like, why do people talk? Like, at, like, a base level, like, why am I streaming this? Why do I think that what I'm saying is, like, should be heard by anyone? It's, like, so unclear. I think, like, motivations in general are just, like, hard to kind of pin down, right? And so you're like, why are you, like, some people will have reasons for watching and they'll be articulated, but a lot of people will just be like, I like it, man. And so I think, like, yeah, it's really hard to answer a question like that. Not just, like, for you, but for me as well. Like, I don't know why I watch most of the content I watch. Anyways, we're getting distracted. So when we update this stuff, we want to reset the buffer with the new data, which means that we bind the buffer. We basically do whatever we were doing down here. We bind the buffer, we set the data. We bind the vertex array, we reset. Yeah. Something like this. Something like this. So we bind the buffer, but this is now self.buffer. This requires an unsafe block, of course. we reset the data with our line points. So this is going to be points i32 vector, but we need to convert the i32 vector into a u8 vector, so we need this shit again. So this is like line points u8, like this. I'm 100% remote, and I like having someone working with me sometimes, so I tune into streams and co-work. I've wondered what the like motivation for those are, because like when you're working in like an office, it's not like somebody's talking all the time, right? Like for me, not that I'm saying that you shouldn't watch, but like if I hear someone like talking, like really talking, it's really hard for me to like focus on whatever I'm doing. So I kind of get like watching like those like that like on YouTube, there's that like animated girl, lo-fi girl with chill beats to chill and relax to. What the fuck are that stream? Like I get like music and I get like ambience, but I would personally really struggle with someone who's like talking in my ear. Weeb confirmed. I mean, I said I get it, not that I watch it. Okay, so we have to bind the vertex array. Set the data, blah blah blah. Set the size. And then we unbind everything. Okay, yep. So I think we're chilling. And that abstraction feels better. Feels better. So now we can construct him initially. Algo progress lines as grid vertices. We construct that guy with emptiness at first. So he's going to be grid vertices new with OpenGL and then 2 empty vectors. Or 1 empty vector, I think. Yup. Then when we update the progress, now we can just say, hey, self algo progress lines update with the lines. Yup. And then all of this goes away. But we still need the GL context here. Yup, okay, that's much nicer. And then down here, we bind the line progress lines array and use the algo progress lines num vertices. Hell yeah, okay, hopefully that gets us there. So we should still see the grid with all the stuff drawn in that one diagonal green line. There we go, we're fucking chilling. So a lot of times you keep the volume low, and so then it doesn't feel like it's too demanding on your brain. Like as you start working, like your brain automatically filters out the low volume shit. I can see that. Okay, so we got through all of that, and now we want to say, hey, when we are stepping through the algorithm, we need to update. It. So first of all, we need to add back some of the code to like actually step the algorithm. So that would be here. We want to add the next button back. And after every time we click the next button, I guess we update. We kind of like draw the lines for where in the algorithm we are. I think that makes sense. So here we would want to do something like pull out the debug info. So I guess that's like this. Let debug info is algo debug info, and then we pull out the lines from this. So let's say like we have debug info dot, what is in this thing? What is in this thing? We have diff algo debug info. Okay. So we want to go like for info in debug info infos. Let's look at the lines here. So info dot, what is in this thing? Steps. Steps is a bunch of line segments. Ah, okay, okay, yeah. So we want to go like info steps windows 2, so we get like the each line segment from these guys. So for window in this gang, and we want to map these to like sets of points, I guess. So we're gonna say like info steps windows to map, and here we're gonna have like A and B, and we're gonna map that into a line with point start x is a x and y is like a0 and a1. This is awful, by the way. Like, I don't like what I've done here at all anymore. I feel like this line abstraction is like wrong because like you could draw line strips, which are a nicer way of doing this, where you say like here's a bunch of points and I can draw them all in a row. But for now, I'm just gonna say fuck it. I don't really want to deal with this right now, so we'll do it this way. It's fine. It's fine. Map takes 2 arguments. Does it? Why? Oh, this would be map AB like this probably. Map, it's window here, and we say let A is equal to window 0, and B is equal to window 1. That's probably what they want. Uh-huh. What the fuck? Steps is a vector of vectors of points. Oh, there's a bunch of lines. Yep. So we actually want... Jesus. So we want like... for line in info steps, we convert that line into our own line. Oh, this is awful. Absolutely awful. Absolutely awful. But we'll figure it out. Gross. So much disgustingness. So I guess here we want to like say let mute lines for rendering is equal to some vector. Here we say lines for rendering extend with all of these things. Oh, it's terrible. What awful code. But it's okay. We live. We just want to keep making progress. We'll clean it up later. And then we say what? Self-rotating triangle, which is not a rotating triangle. And then we update algo progress with the lines for rendering. But he needs the GL context and the nodes. So the nodes are going to be an empty vector. But how do we get the GL context? CTX, GL... Can I like extract it from the eGUI context here? eGUI docs rs. Does he have like a way to extract GL? Glow context. I don't think so. Maybe eFrame has it though? Yeah, here we go. We do have a way to get the glow context from the frame. So here we get the context, so say if let sum GL equals frame GL. This. I guess technically this is an error otherwise if it doesn't work. So we'll say frame GL unwrap. There we go. Okay, please tell me that works. It might not, but it might. So I'm not seeing these updates happen. update algo progress. He's updating the line points. So maybe we'll just say quickly, print line, updating with, oh, it's because we fucking, we left that other code in somewhere. This shit. We're like always replacing it. Fuck that noise. Fuck that. Okay. Oh! That's promising. I don't know if you guys can see it because it's so small. But the green lines are definitely getting drawn in there, which is really good. Let's kind of try to thicken those lines up. Let's try to thicken those lines up a little bit. So I don't really know how to do that. GL line width. All right, GL line width. Nice. Specifies the width of rasterized lines. So I guess down here, when we use the line program, we'll say GL line width, and we'll just set it to like 4. I don't know. Fuck it. Yes, they're visible a little. Nice. Okay, so there we go. So now we can see that like it doesn't look nearly as good as it looked before, but we are seeing the algorithm progress in some way. We're missing some of these connections, but that's okay. I think that's good. I'm happy with that. Happy with that. There's definitely some cleanup to do here. Right, I'm just like not happy with the API I made in general, but I think that in the interests of showing something interesting on stream, I'm going to just kind of plow ahead and then get mad at myself for it later. Okay. Let's look at making sure this guy like fills up the screen, because it's kind of pissing me off that he's not. So that would be here. Iframe canvas. Am I allowed to like say UI allocate space, or what's this, custom painting? Here. He's allocating some size. And can I just say, I don't want to limit this to 300. I want it like as fucking big as you can make it. So UI allocate at least, allocate UI at rect, allocate space. I guess I kind of want I want to keep using exact size, but here I guess I want UI available size. And maybe that'll feel a little better. There we go. That's a lot better. We can actually like see a lot more now, which is nice. Okay. Pretty clearly the like scaling here isn't perfect, but again, good enough for now. Okay. Sub-problem rendering. So before, in like the original version, we were kind of drawing boxes around the sections that like that we split into like the subproblems into. So let's add that back in. So I think, if I remember correctly, we have this in the debug info. We must. So we have top, left, bottom, and right for each section. So here we would want to say like, I guess we can just extend the lines for rendering with the boxes for now. Info.top. Yeah. So we can say something like lines for rendering, extend. I guess we're not drawing the lines like technically like on the grid. So all of these guys being like integer points is kind of annoying, because it would be nice if I could say like draw these like 0.5 away from the grid space. So maybe all of these things should be floats, and that's going to propagate into a massive pain in my ass. But that's okay. That is okay. Because once we get to these guys as floats, then we can specify grid coordinates as like non-integers, and then we can draw a box around them very easily. Very easily. So I think just all of these guys need to be cast from ints to floats. Anywhere here, this would be float now. And then in my vertex shader, this should be, hey, I want like float vectors in. And I wonder if that's enough to get it right. We were close. Not really. We were really far. But we could pretend we were close. So anywhere where we're like constructing points is I32. Can we just look up like as I32 and just like, okay, so this should be x as F32, y as F32, great. F32 here, y as F32, y as F32. This is gonna suck later, but we'll live. Oh my god. Alright. As F32, 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 F32. Oh my god. There we go. Just a couple left, so 449. These should be Fs. And then hopefully I didn't break anything so bad that it doesn't work anymore. We did, though. We did. We sure did. So can we just kind of look a little closer? So here we pass in a bunch of F32s, we bind them, and we say they're floats now. We get the lengths correct. This should be F32 here. And I think there's one more where we had, this should be F32. Hopefully that's good. Fingers crossed. Hell yeah. Everything's still working. Hell yeah. Okay. So now that all of these guys are floating point, we should be able to draw boxes by somewhere. We should be able to say, hey, we're going to like add some lines for rendering. Based off of the points. We're going to say what? Let info top is going to be the top of some box, but it's going to be, we have to subtract 0.5. Okay, so we'll say let top, fine, fuck it, that's fine. Bottom is going to be increased by 0.5. Left is going to be decreased by 0.5, and right is going to be increased by 0.5. And now we have a box to draw, and we can just say lines for rendering, push a line, which has a start of point x top, or I guess it's left, y top, and then the end of this line is going to be top right, I guess. And we have to do this for every combination. So we're actually like combos is going to be something like what? Like top right, top. We're going to go top left to top right. So something like this. Oh, I hate this. I hate this. Yeah, okay. Then we're gonna go top right to bottom right. bottom left to bottom right. And I guess we need to go, like, top left to bottom left. Okay, does that seem right? Left, right, blah, blah, blah. Okay. So then we can say for combo in combos. Lines for rendering, we push the combo. I guess we want, like, A, B in combos, and the start is going to be A0 to A1. We're going to go to B0, B1. Absolutely nasty, but probably correct. Probably correct. Let's see. Let's see. It would be nice if that was it. Okay. We fucked up one of the lines for sure, but it's close. It's definitely close. So it's the right side. So we had right top to right bottom here. There we go. There we go. And then the bottom, it looks like the right side we got the like direction wrong. It looks like we need to increase right by 0.5 here. Yep. Little plus instead of a minus. You know how it goes. All right. That's something. It looks like absolute fucking shit. But I think that's actually enough. It looks like that's actually probably enough to debug to some extent. We haven't done pan zoom yet. But I think we can call the sub-problem rendering good enough to some extent. Okay. Let's try. We'll say try on actual problem case. Because I would like to see just how fucked this really is. So our actual problem case, if I remember correctly, we had a stash. Okay, let's git add -u, git commit -m, OpenGL stuff. I don't know. And let's pop the stash. Surely it won't merge. So can we do git merge tool? And let's see. Here we just take both. So this is stood sync path buff, sure. Also, judge me as much as you want for merge tooling by just fucking opening my editor. I've tried merge tools so often and just had them bite me in the ass so many times that it's just like, I legitimately find this easier. However fucking stupid that is, I actually think this is better. Absolute brain dead, but it's the truth. Okay, so here we're going to take both sets of changes. One of them was like converting to opening a file, and one of them was like opening our A's and B's from a file, and one of these was for converting our like OpenGL renderer. DivTask is really nice. It's powered by Rust and TreeSitter. I did see that online the other day, and it's funny because it's like almost exactly what I wanted to make myself. So we're kind of like wasting our time to some extent. But I'm curious anyway. Like we're gonna keep going, but I do need to check out DivTastic because I originally thought when I started writing my div tool, one of the major reasons that I started doing it myself was I was like, surely something language aware must be possible. I need to build the intuition on like how this like diff stuff works so that I can like figure out how to do that. And surely TreeSitter is a good fit for like language agnostic syntax conversion. And then I was like, oh, this fucking exists now. That's cool. But you know, we'll live. It's cool that it's at the very least, it's cool that somebody else already had the same idea and they're right. Like it kind of like indicates that I was right to some extent. I think this is now A and B like this instead of args A and B. Yep. And are there any more problems here? Nope. Okay. So let's say A, I think we said was spit lock A this was the problem case. So we can start looking at it now. Spit lock B. So first, let's make sure that my memory usage doesn't start going like out the fucking wazoo. Because that's the whole point here. Memory usage is still low, but we are just printing for fucking ever. Right? So let's get rid of some of these print lines. I think that's fine. Okay. Monitoring, monitoring, monitoring. Okay. So, good news. It's so fucking funny. Okay. So, what's happening here? Memory usage is actually okay. CPU usage is off the charts. Or at the very least, like... Oh, maybe it's actually not that bad. Diff is CPU usage 17, 20%. Okay. So, but like what we're seeing is like this like white box is all of the points on the graph like individually rendered, which is pretty funny. It's just like there are so many points on the graph that it's like impossible to see anything. I think it's bad the stream video is laggy. Okay, probably my GPU is just getting railed. Okay. That's pretty funny. But you know what? I expected crashing. Are we back? Let's see. It feels okay. On Twitch, it looks okay. Are we back? Can somebody say if we're, like, good or not? Good now? Okay. Okay, so while it's running, we just fuck ourselves. That makes sense. It's probably because I'm doing transcoding on the GPU. And, the GPU is just getting, like, fucking railed. Is probably related there. But on the bright side, we do have something. Never left, but it was really choppy. Yeah, okay, that makes sense. Was the sound choppy too? Just out of curiosity. Because if the sound was okay, then it's probably fine. Like we'll just be careful about what we are actually showing there. Okay. So I also want to see, maybe. I want to see if we're done or not. So here, when we finish the algorithm, we want to say, hey. Print line. Finished. No, I don't remember the question I asked. Sound was okay. So the no was probably sound. No, I asked was the sound choppy. Was probably what I asked. Okay. So apologies. We're gonna run it again. Oh god, we're back. Okay. So here, if I spam this, we are not getting into the finished case. So maybe what I'll do actually, oh god. Maybe what we'll do is we can just run it to completion instead of spamming the next button. So maybe what we'll do is we'll say loop here when we click the button. And if we finish, then we break. And then that'll immediately get us to the end state, which will be useful for trying to discover how much memory is being used. So if I hit this, we backtrace immediately because, oh, that's interesting. We're hitting this assertion that our forwards and backwards guys aren't running into each other at the right spot, which is different than what we were seeing when we tested it, when we tested it in the Git GUI the other day. I thought that we solved this bug. Interesting. Is this coming from the debug info extraction? This is coming from stepping the linear diff algo. So I wonder why this is different than it was the other day. Maybe we have to check this case as well. It could be that we're hitting, maybe because like we're not allowing it enough memory. Yeah. Max memory bytes. We wanted maybe like Fuck. I'm trying to remember the exact failure case that we were in the other day. It was something like it needed way too much memory. But okay, let's solve the assertion at the very least. So let's go into here and say 01 2500, which, so this time was wrong. Fuck. I used the stream live time instead of the VOD live time, which we can probably actually use to calculate the difference. So right now we are maybe like 9 minutes ahead, so we have to subtract 9 here. So this is going to be like 17. Nice. Nice. And here, what is like the thing we want to do now? We want to like solve assertion. Solve crash on problem case. Because this is not what we were seeing. Okay. And so we can look at the backtrace and we can say he was, in some case where he was doing like the forwards and backwards passes of the algorithm. And when they ran into each other, he goes, what the fuck? I took a different number of steps on one way than the other way. Right? That's what we saw. So we run, we say, hey. What a wonderful kind of day. So Arthur was big into Arthur when I was a kid. Oh, now it's working again. That's interesting. Super interesting. Why is it behaving differently now than last time? Oh, probably because we're hitting the over memory limit error. Let's print line there real quick, and that will give us a bit of a clue. Sorry for the stream lag. Ah, okay, okay. So we're hitting the memory limit, which is fine. So we'll just up this from like 1,000 bytes to like, let's say like 100 megabytes. And let's see if that's enough for this super duper complex diff. And I guess it would be nice to see print line finished here as well. Okay. Come on, Betty. Yeah, okay. So I think I understand what's happening to some extent. It would be nice to be able to zoom in here and look at the nodes a little bit more carefully. But it's pretty damn clear that the minimum case here is still extremely large. So that's pretty sick. So we have like some value from this visualization already. Surely we could have just logged the box sizes and got to the same point. But that's pretty sick. Okay. So let's say we're doing this. And let's try to implement some pan and zoom, because I would like to look a little bit more closely. So we'll say that we are in this case now where we are loading diffs from files instead of from arguments. And let's kind of like reduce back down to a little bit more of like a sane case. So we'll look at A text, B text, nice. And so maybe we can cargo run on our test on A text and B text. And let's just see if we have like a sane graph to play with, which is kind of nice. Nice. Okay, and so now let's go back to trying to like implement pan and zoom, because I think that will be valuable in some way. Okay. So in order to implement pan and zoom, we need to maybe we look for like scroll. So we'll say like response scroll, no, response, like eGUI must tell us in some way if somebody has scrolled on us, and that's what I want to look for. So response, clicked by, secondary, middle, triple, clicked elsewhere, enabled, contains pointer, gained focus, blah, 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 dragged. I guess we could use drag temporarily. I would like to use the scroll wheel, though. I guess we'll Google it. eGUI scroll wheel. Mouse events. If UI contains pointer, okay. So I ask, hey, is the pointer in the area that I drew? And if it is, then let's look for if there was a scroll event. That seems reasonable. Sure. I guess, does that like consume events? No, I think it's fine. Yeah. Okay. So let's do something like UI. I already forgot. It was like contains pointer. UI rect contains pointer, UI contains pointer. Ah, nice. Okay. So if this contains the pointer, maybe we want rect contains pointer. If this contains the pointer, UI ctx input, and we have to do something with it. So I events, and I can specify an event filter. What is like an event filter here? Do I have my, I need a new window again. eGUI docs.rs. Let's look for if there is some sort of like event filter. What does this thing do? Not what I want. Okay, so we'll just look at all the events, I guess. So this guy has like input state. Can I like just get an iterator over all events and then look for a scroll event? Events here. So I just go to the events and look for scroll. Yeah, okay. Sick, okay. So I guess we look for any event that is a scroll event. So we say, hey, eGUI event scroll. And I guess we'll just like filter map these. And so if we get a scroll, we'll just map this directly to the Y axis on this. And otherwise we just say, this is what we're looking for. And then we'll say for Y scroll in this, we have to do something. So I guess we'll say self.zoom plus equals Y. And then we will store that here. Yup. And then local variable exists. What doesn't he like here? He doesn't like Y. Oh, it's Y scroll. Okay. And then we can provide the zoom into the paint request. And then we are going to have to set the zoom on each of these like programs, I guess. So this is going to be an F32. And we have to do it on the line program as well. And so now we need to like set our programs to have like a zoom on them. So I guess we will look at the vertex shader and we'll say, hey, there's a zoom parameter that we can take in. And the X position is going to be multiplied by the zoom. I guess both the X and Y positions are going to be multiplied by the zoom. So X chord times equals zoom. Yeah. And I guess his default zoom value is going to be 1.0. But I guess these are going to be set every frame anyways. So here we just have to make sure that when we construct our visualizer, that the zoom is 1.0 f32. Okay. So let's see what happens now if I just start scrolling on this thing. We should see the grid. Oh god, it's too much. It's too much. It's too much. It's too much. Maybe we print the zoom level. Print line zoom level is this self zoom. Okay. We're probably going to have some sort of scaling parameter on him. Yeah. Yeah, okay. So, clearly this is not reasonable. Over 100.0, just temporarily. There we go, okay. So, probably... That's not that bad. That's not that bad. It's not great, but it's maybe passable. And then probably what we want to do next is we want to add some sort of like panning. So we actually already have something that's like very close to panning. We have this like angle thing that we kind of like inherited from the rotating triangle, which lets us like rotate the graph, which is like fucking stupid. But we can just add in like an X and Y offset. So let's say, hey, X offset and Y offset. And these guys are both originally 0. And we are going to have to pass these over to somewhere eventually, but let's start by, yeah, we stash them as local variables so that they do not act as references to self when we pass them into this closure. Then we give it the X offset and Y offset. This needs, this angle parameter needs to change to X offset and Y offset. The X value is going to be at plus equals X chord plus equals X offset. And probably that should be done before the zoom. Y chord plus equals Y offset. Probably we'll need to scale this by the zoom level. Right, so that we don't... So that the drag is, like, relative to how zoomed in we are, probably. I don't fucking know. What do I don't know shit. But, we'll try that. Here, we'll call angle X offset now, and we'll call Y offset F32. We pass in all of these things. We, instead of saying U angle, we say X offs. And this is X offs here. And we need to do the same for Y. Say, hey, could you find the Y offset position in our program? And we need to give the same treatment to the lines, which kind of indicates that this should be split out in some way, shape, or form, but, you know, future me problem. Future me problem. Okay. So Y is inverted, X, it's moving a little too fast, but maybe fine. So let's at least fix the Y inversion, because I don't want to deal with that right now. Or I was like, I don't want to like deal with, it's going to be a pain in my ass. So where is that code? It's in custom painting here. Yeah, here we go. So the Y offset's going to be minus equals. And then I forgot to check if the zoom level, if it stays like consistent with zoom. So if I zoom in now. Oh god, where am I? Oh no, it's so easy to get fucking lost. Oh no, that's gonna suck. Okay, and if I zoom in, it's manageable for sure. I think it's just it's too fast still, so maybe we, you know, reduce the amount that we're moving just a little bit. Surely there's some sort of like intelligent conversion we can do here, but oh god, Oh god. I think it's when I zoom out below like to 0, it just gets like fucked. But maybe now we have kind of like enough implemented that we could like try to gain some sort of value from this. Let's just kind of see. Oh, baby, look at that. Look at that. How bad is the stream? It doesn't look too bad. You guys said it was choppy but last time, but when I look at it, it's like, it feels okay. Oh, that's so sick. Look at that. So we can just kind of like, the zoom has to be exponential. As we zoom in, it's like too hard to manage, but like it moves too slowly. But yeah, it's super sick. Super sick. Super, super sick. So probably, I think what we're seeing here is that the algorithm, he has this edge case that just like blows fat nuts in the way we've implemented right now. And it's that if you have a long string of like the same text followed by one difference, we end up with this like long diagonal followed by one small modification. And what that results in is like a really large square that like, but that will only ever take 2 steps. So we're probably just way over allocating memory. We're probably seeing like, it's probably something like, we have like, you know, X and Y here. And we're allocating memory essentially on the order of X times Y. Not quite, but like approximately. We're going to skip that. But in reality, the tree that is getting walked only has 2 branches, right? So the only things that we need to remember are this position, and this position. And so in like the algorithm, they kind of like represent X, they translate X and Y into like D and K space. So K is this direction, and D is like how many steps it's taken this way. And the idea is that you like walk this like tree where you say like, for each step in the algorithm, like I'm going to walk left or right, essentially. And these guys kind of in nodes in the tree kind of represent like where you are in this XY space, kind of. It's I'm not going to go into it in too much detail right now. But essentially what we're doing is we're allocating for as if D is like however many steps that it could take if it never took a diagonal, is probably what we're allocating. And in reality, we only have to allocate like that much. Cool. So pretty pleased that the concept of using OpenGL to render this grid, it did let me see something that I couldn't have seen with the old way. It's obviously ugly as fuck right now, and it's like, also it works like shit. The two of those things combined mean that this is Garbo, but it was enough. It was enough. You know? Oh fuck, I lost it myself again. Right, so I think probably what I'll say is I'm gonna call it there. I don't know if I'm gonna commit this version of it. It does seem like it provides significant value in that I can take a real world problem and debug it with this, like, you know, it's just more flexible. So it's probably worth cleaning up. But I have to decide how I want to manage that, if I want to do it on stream or off stream, whatever. So gonna call it there. I'll think about it. If you like what you saw, we stream most days. I've been saying around 1 or 2 Pacific time, but in reality, it's 2 Pacific time. We stream at 2 Pacific time most days. We try to go for like around 2 hours. Today was like an hour 45. You know, it's because we're splitting the difference between what's like a reasonable YouTube video and a reasonable Twitch stream, right? So like when I'm watching these streams, I feel like 2 hours is kind of like my limit, and so that's where I cap it. In reality, I should do some form of video editing, and so then I could stream for longer and cut down the video, but we don't do that. So most days around 2 o'clock. So if you're online around in the hours of like 2 to 4 Pacific time, then swing by if you want, check us out, see what we're working on. Right now we're working on like our Git GUI, right? So this guy, we were also working on like a terminal emulator. Previous projects include operating systems, virtual file systems, neural networks, web development, just kind of like whatever the fuck I feel like is what gets streamed, because this stream is an outlet for me to feel like I'm doing something of value when really I'm just fucking around. So the viz is for the diffing algorithm. Exactly. Yes, exactly. I didn't go into it too much on this stream because I didn't really feel like it was too relevant for what we were trying to accomplish. But yeah, it is like a graph visualization of diff. Yes, where was I? Yeah, if you're watching on YouTube, there's a Twitch link in the YouTube description. If you're watching on Twitch, there should be a YouTube link and a GitHub link in the Twitch description. Some people on Twitch are like don't see the links. So if you are one of those people, it's just the same username everywhere. So Spheriphoria. Yeah, and we'll be back on tomorrow probably, and we will probably be trying to clean up this stack of commits, right? We've got like, this is the last place where it was reasonable, and then we just did like this fuck ton of shit to get to the point where we have like linear diff. So probably we'll try to like clean up that last piece of the linear algorithm so that it like doesn't explode in memory in that one case we just saw, and then do some cleanup. So that's the plan for tomorrow. I think that's all we have to say. Thanks for watching, guys. I hope you enjoyed, and I'll catch you on the next one. Bye!